Hello, this is Peter Hollemans, and this is a presentation on the CoastWatch Utilities, which is a software package for working with satellite datasets. By way of introducing myself, I have a bachelor's in physics and a master's in computer science, and I'm currently a consultant for the NOAA CoastWatch program, and this is a presentation that was given at the CoastWatch OceanWatch meeting in Miami this year, 2016. And what I'll do is I'll talk about the CoastWatch Utilities software features and development. So the talk outline, I'll first talk about the software, the background. I'll show some of the current functionality. And finally, I'll finish up with some notes from the development side. So the CoastWatch Utilities has a wide range of users. Wherever you find NOAA CoastWatch data being used, you can also find the CoastWatch Utilities being used from all the way from government to academic users to private and commercial users. The main functions in the software are to provide a graphical interface for viewing satellite data, command line processing routines for extracting information and manipulating the data, and rendering routines for creating images from data files. The software is available in three main operating system types. The first is Mac, which is the platform that I do the development on. The second is Windows, and the third is Unix. We have Linux and Solaris versions, and we've in the past had other Unix flavors as well. They're all available in 64-bit packages and can be downloaded from the coastwatch.noaa.gov website. Now, in terms of documentation, we have a user's guide in PDF. We have in the CoastWatch Data Analysis tool, which is the main graphical tool in the CoastWatch Utilities CDAT, we have help menu buttons scattered throughout the interface. Something new that we have now is a set of Unix man pages for the command line processing tools. We also have JavaDoc application programming interface documents that are automatically generated from the source code for programmers. And we have now also new a set of YouTube videos that show the basic CDAT usage. You can find those on YouTube by searching for CoastWatch Data Analysis Tool. And CoastWatch is all one word. Now I'll talk about some of the current functionality. So this is a screen that shows the CoastWatch Data Analysis tool in color composite mode, which lets you pick three different bands from a satellite data file, enhance them individually, and display them all together as a red, green, blue composite. And you can do, of course, false color or true color. I've shown in this example a NOAA AVHRR satellite image, channel 1, 2, and 4. The next example here shows color enhancement, which is taking a range of values and a palette and applying it to the data set so that you can see a color image of the data. This is one of the most common usages of the CoastWatch Data Analysis tool, CDAT. Now this next example is showing bit masking, which in this case I've used a cloud mask variable or band in a data file to mask the sea surface temperature data so that you can only see the valid data in the image. The CoastWatch Utilities also has expression masking, which in this case what I'm showing is an AVHR channel 2 image, and I've written a mathematical expression that combines channel 2 and 4 to selectively mask out parts of this image in red. We also have vector overlays, which show lines and polygons on top of the data image from vector data sources, in this case latitude and longitude, coastline, political lines, and also the land polygons. We also have the ability to overlay shapefiles, Esri shapefiles. Now moving on to some of the command line processing routines. This one, for example, CW info, all of the commands are prefaced with CW and then a word. So this is the info command. Shows the contents of a file. So in this case, the metadata, time, date, satellite that data was received from, the sensor, and the set of variables or bands in the file, AVHR, channel 1, 2, 3, etc. We have data statistics commands. This one, CW stats, summarizes the min, max, mean, median, standard deviation, count of valid pixels in a band. We have the coverage program, which displays, or rather creates, an image of where a satellite dataset falls on the Earth. So for example, in this case, I'm showing where an AVHRR pass falls on the Earth. We have a registration routine, CW register, which coupled with a master file, which is a description of the destination grid that we want to map source data to. So for example, here's the source data and here's a destination grid. The registration routine will determine the extents of the destination in the source and then map and register the pixels into the destination grid and write a new file. We have a rendering routine, CW render, which takes a data set and turns it into a PNG, a JPEG, GeoTIFF, PDF, or GIF file, something like this. Next, we have the ability to perform math operations on a file. So in this case, I'm running CW math, and what I'm doing is I'm creating a new variable or band in a file, and I'm calling it diff45, and I'm assigning it values of AVHRR channel 4 minus AVHRR channel 5. So here's channel 4 minus channel 5. They look very similar, but when you actually subtract them, they create a band that is useful for cloud masking of clouds over the ocean. So next up, I'll take a look at the development of the CoastWatch Utilities. Really, the history of the development of the CoastWatch Utilities started at the West Coast Regional Node in 1997, where we created an initial version 0.1, and it was written in C. We needed to handle a new set of operations that we wanted for our website. Later on, the CoastWatch data analysis tool was written, and we had versions for Windows and Linux. And at one point, we converted the CoastWatch Utilities over to Java and then merged in the CoastWatch data analysis tool to create the current package of CoastWatch data analysis tool, which includes CDAT. And then since then, we've just been adding more formats and projections, some extra operating systems, better memory handling, and more processing operations. And this year, in 2016, we have version 3.3.1, which includes, for example, some of the latest features such as GHRSST file support and new GUI features. Now, the architecture of the CoastWatch Utilities is based on reading the HDF or NetCDF data from a file. And there are file input, output, and projection modules written on top to protect the application code in Java from the data, so that we're able to write new file format routines and new projections, and the application code should run independently of what format or what projection is actually being read. Now, the requirements for the CoastWatch Utilities, that is, what it was that has driven the software development, originally came from CoastWatch node operations. After that, we had central operations giving us requirements. And finally, today, we have the NOAA Expo SST group creating requirements for the CoastWatch Utilities and directing their development. So this year, in 2016, we have some new features planned. We'd like to implement NetCDF grid map projections properly. And we have a plan to create a functionality within CDAT for displaying point data from in situ SST measurements. We'd like to implement data processing within CDAT rather than just from the command line. And we'd like to improve the registration performance in the CW register program. In the future, I'd like to see better NetCDF support, specifically around handling metadata flavors. I'd also like to have more unit testing so that it eases development and the creation of new packages. And I'd like to adhere more strictly to object-oriented design patterns. So in summary, I talked a little bit about the software, the operating systems, and the functionality, and the users. I also talked about the current functionality, or at least a subset of the current functionality, and you can find out more about that in the user's guide. And I talked about the development process that has been going on since 1997 and where we're currently with the development. I'd like to acknowledge a number of groups, the NOAA NESDIS AXPO SST group, who is currently guiding the development, CoastWatch Central Node and Operations staff, and CoastWatch data users for making the CoastWatch utilities what they are today. Thanks very much for listening.